Now before we go any further, let's have a look and see how we can use the simulator. Now in previous examples I haven't shown you the actual simulation, which is the left hand panel here. But now I've opened this up so we can see what's inside it, and this will be useful for the rest of the simulations because it will allow you to open up the simulations and follow along with the video lectures. Now I've picked out one simulation in particular, and it's called, at the very top here you'll see it's got a name and it says circular vectoring mode inverse sine. Now this is the simulation that I used in order to work out the inverse sine of a function using the vectoring mode. So the first line you'll have at the top here is always a description of what the simulation is doing. Now you're going to have another set of folders here, and you can see here it's got the initial angle and it's got first approximation, second, third, fourth, fifth, all the way up to the ninth approximation. So we're going to have 9 different approximations here, and we've got 9 little bits of code that we run in order to generate those. Now you don't need to go in here and you don't need to understand what's inside it, but you can always have a look inside and see for yourself, and you can mess about with it and see how it works. But I'm not going to go through a full description of it. That's not really part of the course. I was just using this in order to generate the simulations. So again, you can have a look in all of these and they're all pretty much the same. One follows on from another, and we take the output from the previous and put into the input of the next all the way along, and that's the 9 simulations. Now the next section is the section that we're going to be interested in. The next 2 sections we're going to have the initialization. So you'll see in all of the simulations you're going to have a value for x0, you're going to have your value for y0, and you're going to have your value for z0. So we can set those at this point here. Now you're also going to have another 9 values which I've called rotation angles. So we will be adjusting these values ourselves by particular angles. Now the angles are already set here. So for example, this is a circular vectoring mode. So we're going to be adding on and taking off the angles that we require in the circular mode, and I've already put those angles in. So you can see here we've got an angle of 45 degrees, an angle of 26.566, 565 and 14 and 7 and so on and so forth. And you can see here that we've got them in negative and also in positive because we want to be able to either add on the angle or subtract it off. So these are the values here we're going to mess about with. Okay, so that's those 9 and also these 3 here. But also there's one other complication, and that is that if the output we're interested in is actually the angle Z0, then we're also going to have to add on and subtract off the angles onto this line here in order to get the final value for our Zn. Note that the final value for our Xn and Yn will appear automatically here on the diagram. So let's look at this in 2 modes. We'll first of all look at it in vectoring mode, and then we'll look at it in rotation mode. So we can use this same simulation in order to generate those 2 different modes. But note, this is only going to work in this particular simulation for circular. I've got another file for the linear, and I've got another file for the hyperbolic. So in effect we've got 3 separate simulations, and each of the simulations can run either circular linear or hyperbolic. But also each simulation can run both vectoring and rotation modes. So let's see this example first of all, and then we'll move on to the rotation mode. So in this example, we're using circular vectoring mode. We're going to look at two different outputs. One is a value for our xn, which is going to be the value of x0 squared plus y0 squared and the square root of that. So that's going to be one of our outputs, and it should be approximately 1.8411. Now the other output we're going to look at is the value for our Zn. Now we've not got it written down here in this particular example, but the Zn is going to give us the inverse tan of the y upon x. And we'll see both of those outputs and how we generate them here on the right hand side. So we'll start off with what we have here at the moment. We're going to put in a value for our x0 is 1 and y0 is 0.5, so you can put those in here. So we can put our 1 and we can put our 0.5. Now the value here in this instance for z0 is going to be a value of 0, so we can just leave that the way it is. Now we're going to be using vectoring mode. So what the vectoring mode tells us is that we're going to subtract off the certain angles in order to ensure that the height of this vector here tends towards 0. And we know our angles that we have here. So I can quickly look at this and say, well, this value here for our yi is going to be as a positive value. So I'm going to have to subtract this angle off first of all, and I'll do that just now. So the first angle we subtract off is the 45. So you can see we're going to take the 45 degrees off. And now we can see that the value for yi is less than 0. So now we're going to have to add the next one on. So you go to the next one in the list here, and we now add it on. And we can see the value is positive. So now we're going to subtract it off. Now in each time all we need to do really is look at this number here. This number here is negative. So now it's negative, we know we're going to have to add the next one on. And you can see the number is now positive, so we're going to have to subtract the next one off. And now it's negative, so we add on. And it's remained negative, so we're going to have to add the next one on. We're now positive, so we can subtract off. And finally, we're now negative, so we can add that one on. So that's us adjusted all of these, added and subtracted all of these angles on to ensure that our y tends towards 0. So in effect, our yn is now equivalent or approximately equal to 0. Our xn should be equal to this number here, 1.8411. And you can see here that we've got 1.8407. So we're very, very close. So that's us found the value for our xn, which gives us this little output here using the vectoring mode. But now we have another function that we can generate here, and it's the arctan. Now the arctan is generated via this same process, but instead of looking at the output here in terms of xn, this length, we're interested in looking for the output of the value of our z. Now we started off with z is equal to 0. So in order to generate the correct value for z, what we're going to have to do is we're going to have to add on and subtract off these same angles to our value z0. And I'll zoom out here a little bit. We're not really interested in what's in the drawing here at the moment. So what we're going to have to do then is we're going to have to look at this angle and we say, well, the angle is minus 45. So in here what we're going to do is we're going to put in plus 45. and now the angle is plus 26.565. So we're going to have to put in the angle of minus 26.565, and again the angle is positive 14. The angle is minus 14, so we're going to have to make this angle up here positive. So what we do then is we work through each of these in turn, and where we see a negative angle here, we make it the positive, and where we see a positive angle here, we make it negative. So I'll go ahead and do that with these 9 values. So I've gone ahead and added on and subtracted off these angles from our Z0 in order to get a final output Zn. So the final output we have here for Zn is going to be 26.4522 degrees. So what we want to do is just check here, and we can use a graphical calculator. So what we've said is that the output for this particular algorithm here for the circular vectoring mode is going to give us the arctan of our y0 upon x0. So our y0 is a value of 0.5, x0 is a value of 0.1. So we're going to have arctan 0.5 upon 0.1, which is just arctan of 0.5. So we're expecting to get the output value 0.46364. Now we get an output, but the output we get is an angle, and the angle we get here is 26.4522 for our final value for Zn. So what we do is we take the 26.4522, we multiply it by pi, divide it by 180, and that gives us our final value in radians. And you can see this value here is 0.4616, and that's an approximation to the value that we have above, 0.4636. So this does work, and this is us using the simulator in vectoring mode. So let's go ahead and we'll see how we use the simulator in rotation mode. So that's me reset the simulation such that all of the angles and all of the initialization values are at 0. Now we're going to use this same simulation file, but we're going to use it in rotation mode. So we're not going to be using this little section here. This was just for the vectoring mode. But we are going to have an input still for x0 as a value of 1, and y0 is going to be a value of 0.5. And we're also going to have an angle z0 for the initialization angle of 30 degrees. So you can see here we've got the two vectors. Now the vector in blue is the z0 value, and this will give us our final Zn. And the vector here in pink is going to give us our xn and our value for our yn. But we're only going to use one vector at a time because it's easier to see how the simulation works. So in this instance here, we're going to be adjusting the value for z0. So we're going to make the angle z0 tend towards 0. So previously in the vectoring mode, we would be looking at the vector here in pink, and we would be making the value for our height here tend towards 0. But now we're not doing this. In the rotation mode, we're taking this vector here and we're going to ensure that the angle here tends towards 0. So we're going to have to add on and subtract off the values from this point here. Now in the circular mode, we're going to be adding and subtracting off these same angles. So you can see here that the angle is positive, so I would have to subtract off the first angle, which is our 45 degrees. Now the angle is negative, I'm going to have to add on the next angle, and the next angle is this 26. and I'll be adding that one on. And again, now the angle is positive, we're going to have to subtract off the next angle, which is this one here. And now this angle is negative, we're going to have to add on the next angle. So I'll go ahead and I'll add on and subtract off these angles. So I have gone ahead and added on and subtracted off the angles from this initial angle of Z0, which was 30 degrees. So by adding on and subtracting off these angles, the value for our Z0 tends towards 0. So in fact we've got a value of 0.0322 degrees. So you can see the vector now runs along the x-axis. So now that we've got this value down to 0, we're going to have to add on and subtract off the same angles to this vector here. But of course, we add those on and subtract them off down here. So we don't start off with the first angle here because this was our angle Z0. We're going to be adding on, subtracting off these angles. And again, it works the opposite way. We're subtracting off the 45, therefore we add on the 45. We're adding on the 26, therefore we subtract it off. We're subtracting off, therefore we add it on. Now I'll go ahead again and do the rest of these. So that's me going ahead and subtracted off and added on all of the 9 angles. Now the output we're interested in now is not the value of our Zn. We're interested in the output for our Xn and Yn, which is the final point up here. Now this particular algorithm isn't actually one that we've covered here in the course, but the output should be of the form the value Kn times the value for our cos of our 30 minus the Yn, which is 0.5, times the sine of the 30. And also the value for our Yn is going to be given by our 1.65, which is the value of our Km, so in effect it's 1 over the gain factor, is equal to the value for our Yn, which is 0.5, times the cos of our initial angle, which is 30 degrees, and the value of our plus sine of the original angle, which is 30 degrees. But note, of course, the angles have to be changed into radians, so I've multiplied those by pi upon 180. So it doesn't really matter too much about why this is the particular output. All we're interested in is just to show that it does actually work. So the value we're expecting to get from this simulation for our Xn is the value of 1.01644, and you can see we've got 1.0144, and the value for our Yn we're expected to be 1.539, and we've got 1.536. So this does work, and this process works, and that's an example of our working through the simulation in rotation mode. So in vectoring mode, we set up the initialization values x0, y0 and z0. We then add on and subtract off these angles to ensure that the value of y0 tends towards 0. So then whenever the y0 is tended towards 0, the final outputs can be chosen as either the value for our Zn, which is here, or the value for our Xn, which is here. Now in order to get the Zn, we're going to have to add on and subtract off these angles here, but we do it in the opposite sense. So for example, if we subtracted off the angle here, we'd have to add on the angle here. If we added on the angle here, we'd have to subtract off the angle here. So that's vectoring mode. In the rotation mode, we're going to again set up the initialization values, which are x0, y0 and our z0. Now we're going to adjust the value for our z0 such that the final value tends towards 0. So we're going to be again adding and subtracting off these angles, but we're going to be doing it from this point here. Now, when we've added and subtracted these angles, the final angle for our Zn will have tended towards 0. That means that the final output that we're going to get will either be our xn or our yn. So that's how we run this simulation using vectoring and rotation modes. Now if you've got any problem with this, it can be quite confusing, then just give us a shout and I can talk over with you. Thank you for listening. I'll get you on the next video. Goodbye.